So in this video we'll discuss the K-map implementation of full subtractor. Okay, the K-maps implementation of full subtractor Karnaugh map. So we have the full subtractor, the block diagram is given by this. There are three inputs, the 2 bits to be subtracted and the input borrow. A, B, the 2 bits to be subtracted, minuend and subtrahend, and the input borrow. And 2 outputs, one is difference, one is borrow output. The expression for difference is given by A bar, B bar, bin, or A bar, B, bin bar, or A, B bar, bin bar, or A, B, bin, which is A XOR B XOR bin. Okay, the XOR of the 3 inputs. Now if we have to implement it through a K-map, see if we can minimize it. So what we'll do, we'll draw a 3 variable K-map. Okay. Okay. So we draw a 3 variable K-map. So on one side we'll take the A and the other side B, B. So we have 0, this is SOP, sum of products min term based K-map. So 0, 1, then 0, 0, 0, 1, 1, 1, 1, 0. What is the rule? For every simple variable without bar or without complement, it is 1. For the complemented variables, it is 0. Okay. So 0 means it is A bar, this is A. And let me take it a bit downwards. Okay, it's almost touching. Okay, here. So this is B bar, bin bar, this is B bar, bin. Always write it in the same order which you have written here. B bin means first B then bin, and this is B bin, both are 1, so no complement, and this is B bin bar. So I have already discussed Karnaugh maps. You can refer to Digital Electronics playlist where I have discussed everything: 2 variable, 3 variable, 4 variable, 5 variable K-map, all the basic concepts, a lot of questions. You can refer to Digital Electronics playlist for that. So now for all these min terms that are present here in the difference Boolean expression, we'll put 1 in the respective cells. So we have A bar, B bar, B in. So A bar, B bar, B in. So we'll put a 1 here. Then we have A bar, B, B in bar. A bar, B, B in bar. Okay, 1 here. Then A, B bar, B in bar. Okay, A, then B bar, B in bar. Okay, here. Then we have A, B, B in. A, B, B in. So here. Now here we cannot form any groups. We cannot form pairs. We cannot form quads, and octet is out of the question because there are 4 occupied cells. Because we cannot form pairs when the occupied cells are across each other. They should be adjacent to each other, not across, directly across each other. So we'll form single member groups. Okay, this. So here there is no scope of any minimization of this Boolean expression. The above Boolean expression cannot be further minimized. This is the minimized form. We cannot minimize it further. Okay, because there is no possibility of any multi-member group formation, more than one member group formation. Okay, then for the borrow. Now the borrow is expressed as the lengthy one I'm talking about. It is expressed as A bar, B bar, B in, or A bar, B, B in bar, or A bar, B, B in, or A, B, B in. Okay, this. Now again a 3 variable K map will draw. So I'm drawing it here so that there is a bit space. Again same, A on this side, B, B in on the other side. Then first 0, then 1, then 0, 0, 0, 1. Always remember this part. This is 1, 1, then 1, 0. Most of the students, they make the mistake whenever they are starting with this. They do 0, 0, 0, 1, 1, 0, 1, 1. So it is 0, 0, 0, 1, 1, 1, 1, 0. Okay. So now we will occupy, we'll write, okay, we have to write, this is A bar, this is A, this is B bar, B in bar, this is B bar, this is B in, this is B, B in, this is B, B in bar. Okay. So now we have to occupy the cells. So A bar, B bar, B in. A bar, B bar, B in. Okay, here 1. A bar, B, B in bar. A bar, B, B in bar. Okay, this one. A bar, B, B in. A bar, B, B in. This one, then A, B, B in, A, B, B in. Okay, this one. So here we can form a lot of groups, lot of pairs actually. The first pair which will form is this. The second pair which will form is this. The third pair which will form is in between these two cells, occupied cells. So now from these pairs we have to identify the common variables. So for this pair, the common variable is A bar from this horizontal side, and on the vertical side we have B in common. So A bar, B in. If you remember the rules, I have discussed it in K-map, okay? So A bar is common and B in is common. From the vertical side B in, and on the horizontal side in both the cells A bar is common. Then for this cell, on the horizontal side nothing is common. Here it is A bar, here it is A. On the vertical side we have B in common. Then we have for this pair, this group, on the horizontal side we have A bar common, on the vertical side we have B common in both the cells. So it is A bar B. So this is the simplified Borrow output, A bar B in or B in or A bar B, which we have discussed in the basic concepts in the introductory video. I told you that I will show you through K-map how we can minimize it to get this expression of output borrow. There are different expressions also. We saw XNOR expression A bar B or A XNOR B into B in. That also I showed you in that video, how to minimize it through Boolean simplification, how to simplify it and get that required output. So this is the simplified minimized expression of output borrow. So for difference there was no scope of minimization, but for borrow there was scope for minimization and we minimized it. So this is the lengthy expression, this is the simplified expression. Okay, so here we discuss the K-map implementation of full subtractor for difference and output borrow expressions, output expressions.